Hello and welcome to lesson 15, the central limit theorem. Well, if you watched lesson 14 video, then you know I used the z formula, x minus the mean divided by the standard deviation. And for the central limit theorem, we do the exact same thing, except instead of having one object, one bear or one person, we're going to have a group of n. So that means when I do the z formula, there's one extra part. I need to divide the standard deviation by the square root of n. Otherwise, the work is going to be the same as lesson 14. So with this one, it doesn't have much of a story. It's just that the mean is equal to 100. So that goes in the middle of the bell-shaped curve. And the standard deviation is 15. So I have mean equals 100 and standard deviation equals 15. This is the sample size, so it's n equals 10. And then find the probability the sample mean is over 110. So 110 would be right here, and I usually write x equals, but this is the average for those 10 people. And then this is the line where it's equal to 110, and then this is saying over, so that means shade to the right. And I'm going to do it one time with the formula and the table, and then use the calculator after that. So using the formula, it goes like this. The z equals, take the score of 110 minus the mean, which is 100, then divide by the standard deviation, and then that gets divided by the square root of n, which in this case is 10. And when I do this on the calculator, I'm going to put parentheses around this and parentheses around this. So the calculator understands this is the top of the fraction and this is the bottom of the fraction. So paren, 110 minus 100, other parenthesis, divided by another parenthesis, 15 divided by, and then don't forget square root is over here, second square root of 10. And then go to the right to stop the square root and then put the last paren. So this, when I use the table, I have to round to 2 decimals. So that means that that little 8 at the end is going to make it a 2.11. So I get z equals 2.11. And then this is a positive z-score, so I use table A2 with the positive, and then I'm looking for 2.11. So right here, it says 2.1. So it's going to be this row right here. And then this column says if the last decimal place is a 1. So it's going to be this column, follow it down, and then that says 0.9826. 9826. But that means that the left side is 0.9826. Because remember, when you use this chart, it's giving you what's on the left. So to find out what's on the right, then I just need to go 1 minus 0.9826. 1 minus 0.9826. And it is a 0.174. 0.174. Now, with the calculator, if you look at the distributions, so there's the normal distribution, but the problem is nowhere in here can I put n equals 10. So that means the calculator will not do this for us, unfortunately. So we need to actually do this ourselves. You know what? Let me just look and see, is there anywhere that says the central limit theorem or anything like that? No, nothing like it. So unfortunately, this one is not in the calculator, so you do need to use this formula. Then you would get the z. And if you don't have or don't want to use the table A2, then after doing this formula, you can go to the normal distribution. Oops, I just put it twice. And then say the lower is 2.11, and then it would go to the right of that. So just put some large number, and then use the mean is equal to 0 and the standard deviation is 1. And then it says the exact same answer is what I got. But we do have to do this formula every time when it's the central limit theorem, which you'll know when it says you've got a sample size. And then for the next example, so I'm still using that the mean is equal to 100 and the standard deviation is equal to 15. So that means 100 goes in the middle. This time it's a sample size of 20. So n equals 20. And then find the probability that their sample mean is between 95 and 105. So 95 would be over here on the left. 105 would be over here on the right. And then between means shade the area between. So that means we do need to do the z formula for each one. And I don't think I have enough space right here where I usually like to write it. So I'm gonna have to write it over here. So z equals, take 95 minus the mean of 100, divide by the standard deviation of 15, and then that gets divided by the square root of n, which is 20. And then my red pen reminds us, make sure you put parentheses and parentheses. So then parentheses 95 minus 100 divided by parentheses 15 divided by the square root of 20. And that is a z of, now if I was going to use the table, I would actually round it, but because I'm going to use the calculator for this last part, I'm not going to round it. I'm just going to leave it like that. Negative 1.4907. And then do the other z-score for the 105. Z equals 105 minus 100 gets divided by 15, and that gets divided by the square root of 20. Parentheses, parentheses. So sometimes to save time, you can just screen grab it and then back up, because there's only one number that changed, and this is a 10, and then I have to put second insert the 5. Or if you have an extra 8 seconds, just retype the whole thing. And because both of these are 5 points away from the middle, it gives us the same number except positive, because the graph is symmetric. All right, and then for the last part, find the probability that a score is between these two z values. So second distribution, number 2, and then go from a negative 1.4907 to a positive 1.4907. And right now we're just using the z-scores, so just leave this as 0 and 1, and then paste, and the area is 0.8640. So this area is 0.8640. All right, then just one more. So the mean is still equal to 100. It's a sample size of 10, so n equals 10. And then it's asking about 89, so 89 would be over here somewhere. And then the word at most means less than or equal. And less than or equal, well, this arrow is pointing to the left, so you shade to the left. Okay, so one more time, just do the z formula. So z equals the 89 minus 100, and then that gets divided by the standard deviation, and then the square root of n. And of course, the red pen wants his chance to say, don't forget the parentheses. Okay, parenthesis, 89 minus 100, divided by parenthesis, 15, divided by the square root of 10. And then get out of the square root and put the last paren. So z equals a negative 2.319. So z equals negative 2.319. It had a 0 at the end, but that doesn't add anything to it, so you can just have it like that. And then use the normal distribution again. So this is going to go from the lower is way over here at like negative 10,000 until it gets to negative 2.319. And then just leave this as 0 and 1. And then the area is, so as you can see, the area is very small. It's 0.0102. So this area is 0.0102.